Good morning, students. In the previous class, we discussed about the structural isomerism and the types of structural isomerism we are discussed in the previous class. In this class, we are going to be discussing about the second type of isomerism that we call as a stereoisomerism. In this class, we are going to be discussing about the stereoisomerism. What is meant by stereoisomerism? Here, the two or more compounds having the same molecular formula but differ in the spatial arrangement of atoms. That is, the differ in the spatial arrangement of atoms is called as a stereoisomers. The phenomenon is called as a stereoisomerism. Here, the two or more compounds, ಎರಡು ಅಥವಾ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ compounds same molecular formula ಇರುತ್ತೆ, but differ in the spatial arrangement of the atoms or the groups. Atoms ಆಗಿರಬಹುದು ಅಥವಾ groups ಆಗಿರಬಹುದು, ಅದು differ ಇರುತ್ತೆ ಅರೇಂಜ್ಮೆಂಟ್ ಅಂತದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ, stereoisomers ಅಂತ ಕರಿತೀವಿ. That phenomenon is called as a stereoisomerism. Means here the stereoisomerism is, again we are going to be classified into two types. That is, one is geometrical isomerism. Geometrical isomerism. Geometrical isomerism. Then next is optical isomerism. So first we are going to be discussing about the geometrical isomerism. We will discuss about the geometrical isomerism. Yeah, the geometrical isomerism means, in this also we are going to be define the type of stereoisomerism. Is a type of stereoisomerism. In this, that is the two or more compounds having the same molecular formula, even same structure. It's having the same structure, but the arrangement of groups are atoms. The groups are atoms. Around a carbon-carbon double bond is different. The arrangement of groups are atoms around a carbon-carbon double bond is different. That we call as a that is geometrical isomerism. That we call as a geometrical isomers ಅಂತ ಕರೀತೀವಿ. ಆ phenomenon ಏನಂತ ಕರೀತೀವಿ, that we call as a geometrical isomerism. We'll take the example. The butene. Here we are going to be taking the example for this is, there is a butene. In this, there is a carbon. Here the main we are going to be taken as a carbon-carbon double bond. The carbon-carbon double bond means I write the carbon-carbon double bond. Then here the CH3 group is attached. Here hydrogen. Then here CH3 group. Then this one is a hydrogen. Here the same groups, that is methyl groups, is above the double bond and hydrogen atoms below the double bond. Means this type of isomer we call as a cis isomer. This we call as a cis isomer if the arrangement of the identical groups in the opposite direction, that we call as a trans isomer. That I am going to be written. That is a CC double bond, then hydrogen, CH3, here CH3, then here H. This we call as a trans isomer. And cis isomer alli one identical groups is arranged in the same side, but in the trans isomer the identical groups is arranged in the opposite side. That we call as a trans isomer. This pair of isomers we call as a geometrical isomers. The phenomenon is called as a geometrical isomerism. Because same molecular formula ಇದೆ, but differ in the arrangement of groups around the carbon-carbon double bond. ಇಲ್ಲಿ ನೇಮಿಂಗ್ ಮಾಡೋದು carbon 1, 2, 3, 4. This is the compound name is butene because 4 carbon atoms are there. Then second carbon is consisting of the double bond, therefore U2E. The name of this compound is U2E. So this is the example for that. That is geometrical isomerism. The next we are going to be discussing about the second type of stereoisomerism, that is optical isomerism. Optical isomerism means here the two or more compounds having the same molecular formula but differ in the rotation of plane polarized light. Means ಇಲ್ಲಿ ಸೇಮ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಇರುತ್ತೆ, ಎರಡು ಅಥವಾ ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ಕಾಂಪೌಂಡ್ಸ್ ಸೇಮ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಇರುತ್ತೆ, ಬಟ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಡಿಫರ್ ಇನ್ ದ ರೊಟೇಷನ್ ಆಫ್ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್. That we called as a optical isomers. Then the optical isomers, the phenomenon is called as a optical isomerism. That phenomenon we called as a optical isomerism. Here the one is dextrorotatory, another one is levorotatory. That example for this optical isomerism. Example for the optical isomerism is, that is, it's going to be indicating dextrorotatory by plus, that is dextrorotatory on the right side. If the compound rotates the plane polarized light to right, means that we called as a dextrorotatory. Otherwise we are going to be indicating by the plus charge. Means the example for is plus lactic acid. Example. Then the levorotatory means it's going to be indicating by the minus sign, that is levorotatory. In this that is example for this is minus lactic acid. Means here the plane polarized light is going to be rotates towards the left. That compound we call as a levorotatory compound. Means this that is plus lactic acid and minus this lactic acid we called is the example for the optical isomers. The phenomenon is called as optical isomerism. Means either it is going to be rotates either right or left. Right ge rotate madre adana dextrorotatory anta karitvi, left ge rotate madre adana levorotatory anta karitvi. This about the stereoisomerism. Illi ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು ಏನು stereoisomerism ಅಂದ್ರೆ ಏನು, ಮತ್ತೆ ಅದರ ಜೊತೆಗೆ ಅದರಲ್ಲಿ two types of stereoisomerism, that is geometrical isomerism and optical isomerism. Geometrical isomerism ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಅದರಲ್ಲಿ ನಮಗೆ ಸಿಸ್ ಟ್ರಾನ್ಸ್ ಅಂತ ತಗೊಂಡಿವಿ ಐಸೋಮರ್ಸ್ ನ. ಸಿಸ್ ಅಂದ್ರೆ ಸೇಮ್ ಸೈಡ್ ಇದೆ, ಐಡೆಂಟಿಕಲ್ ಗ್ರೂಪ್ಸ್ ಸೇಮ್ ಸೈಡ್ ಇದ್ರೆ ಸಿಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಐಡೆಂಟಿಕಲ್ ಗ್ರೂಪ್ಸ್ ಅಪೋಸಿಟ್ ಸೈಡ್ ಇದ್ರೆ ಅದನ್ನ ಟ್ರಾನ್ಸ್ ಐಸೋಮರ್ ಅಂತ ಕರಿತೀವಿ. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಆಪ್ಟಿಕಲ್ ಐಸೋಮರಿಸಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಆ ಕಾಂಪೌಂಡ್ಸ್ ರೊಟೇಷನ್ ಮೇಲೆ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ರೊಟೇಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಈ ರೈಟ್ ಟುವರ್ಡ್ಸ್ ದ ರೈಟ್ ಅಂದ್ರೆ ಡೆಕ್ಸ್ಟ್ರೋರೊಟೇಟರಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಟುವರ್ಡ್ಸ್ ದ ಲೆಫ್ಟ್ ಅಂದ್ರೆ ಲಿವೊರೊಟೇಟರಿ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದಟ್ ಈಸ್ ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ಈಸ್ there is a dextrorotatory lactic acid, levorotatory lactic acid. The next we are going to be discussing about the fundamental concept related with the organic reaction mechanism. Next we are going to be discussing about the fundamental concepts. These are fundamental concepts in organic reaction mechanism. Organic reaction mechanism. Here, the fundamental concepts in organic reaction mechanism. A chemical reaction occurs. Yavagavate chemical reaction when the reactant reacts with the reagent. When the reactant reacts with the reagent, it's going to be formed an intermediate. This intermediate going to be again it's going to be gives the product. ಏನಾಗುತ್ತೆ, ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ ಯಾವುದ್ರ ಜೊತೆ, is the reagent today. Organic molecule. Organic molecule. It's going to be attacks the reagent. Attacks reagent. Then it's going to be formed that intermediate compound. Then it's going to be gives the product. Here the first organic molecule is going to be attach the reagent. Then it gives the intermediate compound. Then we are from intermediate product we are going to be get the product. The next we are going to be discussing about the fission of covalent bond. That is the fission of covalent bond. Fission of covalent bond. Here the most of the organic compounds usually contains the covalent bonds. That is the breaking of the covalent bond. Breaking of the covalent bond is called as, that is the cleavage of covalent bond. Otherwise it's called as a bond fission. Means dividing. The bond is going to be divided. The bond fusion or cleavage of the covalent bond is called as. Here this is going to be takes place in the two ways. That is the first one is homolysis, that we call it as a homolysis. That is otherwise it's called as a homolytic bond fission. Homolytic bond fission. The second one we call as a heterolysis or heterolytic bond fission. Heterolytic bond fission. Here the one is homolysis, homolytic bond fission, or heterolytic bond fission. It's called as a heterolytic bond fission. Here the first we are going to be discussing about the homolysis. What is meant by homolysis or homolytic bond fission? Homolysis means if the shared pair of electrons in a covalent bond, if the shared pair of electrons in a covalent bond is distributed equally to the bonded atoms, that we call as a homolytic bond fission, or the process we call it as a homolysis. ಏನಾಗುತ್ತಂದ್ರೆ ಶೇರ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತಲ್ಲ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಅಲ್ಲಿ ಈಕ್ವಲ್ ಆಗಿ ಶೇರ್ ಆಗುತ್ತೆ ಬಾಂಡೆಡ್ ಆಟಮ್ಸ್ ಗೆ. ಎರಡು ಸೈಡ್ ಇರುತ್ತಲ್ಲ ಆ ಬಾಂಡೆಡ್ ಆಟಮ್ಸ್ ಗೆ ಈಕ್ವಲ್ ಆಗಿ ಶೇರ್ ಆಗುತ್ತೆ ಅಂತದನ್ನು ನಾವು ಹೋಮೋಲೈಟಿಕ್ ಬಾಂಡ್ ಫ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. That example for this is that is in between the chlorine. That is in between the chlorine or in between the hydrogen and hydrogen. The cleavage of the chlorine molecule. Yeah, the cleavage of the. We take the example. First, we take the chlorine molecule. Cleavage of the chlorine molecule. Yeah, these shared pair of electrons is there. No, it's going to be. That is, these electrons is equally distributed between both the chlorine atoms. It's going to be formed that the chlorine free radicals. That is, we call it the chlorine free radicals. This we call as the free radicals. And then one unpaired electron is going to be left with the each atoms or each group, that we call as a free radical. We call as a free radical. If suppose we are going to take the cleavage of the hydrogen molecule, the cleavage of the covalent bond between the hydrogen and the hydrogen is going to be used the hydrogen free radical. That is going to be indicating by the dot, that we call as a free radical. These are these free alkyl free radical. When classification of alkyl free radicals, That is, when it comes to that classification of alkyl free radicals. When it comes to the classification of alkyl free radicals, that is, first one is primary. First one we call it as a primary, which is attached to the only one carbon. Attached to only one carbon, that we call as a primary. Secondary means which is attached to two carbons, and tertiary, that is, these are attached to 3 carbon atoms. 3 carbons means we take that the stability of these free radicals is, that is, the methyl free radical. The methyl free radical is less stable than the primary free radical. Primary free radical is less stable than the secondary free radical. Then secondary free radical is less stable than the tertiary free radical. That is tertiary free radical. This about the stability of the free radical. Stability of the primary. Primary. This is the methyl free radical. This primary alkyl free radical. Secondary alkyl free radical. Tertiary alkyl free radical. ಈ ಕಾರ್ಬನ್ ಒಂದು ಕಾರ್ಬನ್ ಮಾತ್ರ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಈ ಕಾರ್ಬನ್ 2 ಕಾರ್ಬನ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ, ಇಲ್ಲಿ 3 ಕಾರ್ಬನ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. But only as I said, this primary means it is attached to only 1 carbon, secondary means attached to 2 carbons, tertiary means it is attached to the 3 carbons. This is about the homolysis. That is, homolysis or homolytic bond fusion. ಅಂದ್ರೆ shared pair of electrons equal ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆದ್ರೆ ಬಾಂಡೆಡ್ ಆಟಮ್ಸ್ ಗೆ ಅದನ್ನ ಹೋಮೋಲೈಸಿಸ್ ಅಂತ ಕರೀತೀವಿ. ಅಲ್ಲಿ ನಮಗೆ ಫ್ರೀ radicals ಫಾರ್ಮ್ ಆಗುತ್ತೆ. These are there is no any charge in this neutral atoms. This we call as a neutral atoms. The next we are going to be discussing about the electrolysis or electrolytic bond fusion. That is, electrolysis or electrolytic bond fusion. In this electrolysis means that is the shared pair of electrons are unequally distributed the bonded atoms. Unequal ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಯಾವ ಬಾಂಡೆಡ್ ಆಟಮ್ಸ್ ಗೆ ಅಂತದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ಹೆಟ್ರೋಲೈಸಿಸ್ ಅಂತ ಕರಿತೀವಿ. Otherwise it's called as a heterolytic bond fusion. This suppose A and B are there. That is, A is bonded to B. This is going to be form a bond. These two shared pair of electron. It is going to be used either the A is going to be acquire all the electrons towards it. Either B is going to be all the electrons. Means at that time, if suppose A is going to be acquire both the electrons, means that we call it as a negative species, and it will be gets the positive charge. Suppose B acquires all the electrons, at that time A gets the positive charge and B gets the negative charge. We know that the positive charge indicates the electron deficient and negative charge indicates the electron rich ಅಂತ ಕರಿತೀವಿ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಅದನ್ನ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಂದ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಮ್ಮಿ ಇದ್ರೆ ಅದನ್ನ ಡಿಫಿಷಿಯಂಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಂದ ನಾವು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ. In this that is electrolysis of methyl bromide. We take an example, that is electrolysis of methyl bromide. that is CH3Br. Here the electrons, the shape pair of electrons is shifted towards the bromine. Therefore, that is methyl group gets the positive charge and this bromine gets the negative charge. Means during the heterolytic cleavage, the carbon gets the positive charge. That species we called as a carbocation. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ ಅದೇನಾದರೂ ಕಾರ್ಬನ್ಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದರೆ ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಕ್ಲೀವೇಜ್ ಅಲ್ಲಿ ಆ ಕಾರ್ಬನ್ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಅಂತ ಕರಿತೀವಿ. ಆದರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬಂದರೆ ಅದನ್ನ ಆನಯಾನ್ ಅಂತ ಕರೀತಾರೆ. ವಿ ಕಾಲ್ಡ್ ಹ್ಯಾಸ್ ಎ ಆನಯಾನ್. ಅದೇ ತರ ಸಪೋಸ್ ಇಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಆಫ್ ದಿ ದಟ್ ಈಸ್ a cleavage of the under that is CH3Z. It is going to be shift towards the methyl group. At that time, that is CH3 minus plus Z plus. This we call as a carboanion. Andre negative charge bandre carboanion, positive charge bandre carbocation. In this, that is primary carbocation. Yadu methyl carbocation is less stable than the primary carbocation. Primary carbocation is less stable than the secondary carbocation. Secondary carbocation is less stable than tertiary carbocation. Then, like this only, we'll take that the anions. That is the methyl anion is more stable than the primary anion. Then primary anion is more stable than the secondary anion. Then the secondary anion is more stable than the tertiary anion. This is about the stability of the carbocation and carboanion. ಅಂದ್ರೆ ಕಾರ್ಬನ್ ಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಕ್ಲೀವೇಜ್ ಅಲ್ಲಿ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಅಂತ ಕರಿತೀವಿ. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ರೆ ಅದನ್ನ ಕಾರ್ಬೋಆನಿಯನ್ ಅಂತ ಕರಿತೀವಿ. ಇದು ಸ್ಟೆಬಿಲಿಟಿ ಆರ್ಡರ್. This is about the stability order of the carbocation. This is about the stability order of the carboanion. This about the fusion of covalent bond. These two types of homolysis and the heterolysis of bond fusion.